We've just made it through assignment 3 for REM 411, and there were a few things that I just want to pass along to perhaps improve future assignments in this class. First of all, make sure to cite your sources and make sure to use sources. We've been talking a lot about this, but here were a few good examples in class. One student said that the Palouse remnants makes up about 1% of the original Palouse. They are mainly found in hillsides that are too steep or rocky to farm, or cemeteries like the one we visited. That's fine. We talked about that in the field, but there's no reference given. I don't know where that information came from. Now look at the second student. They talked about the Palouse Prairie as one of the most endangered ecosystems in the U.S., and they cite a source, NOS, 1995, and apparently only a little over 1% of the historic prairie exists today, again citing NOS, and then this person put the reference at the end of the document as you're supposed to, and this is a really reputable document that was in a book by the Biological Survey, and it could be found in the library. So that's a good case of making an important point, but substantiating it with published literature, because 1% of the prairie remaining is not common knowledge. It's something you had to read somewhere. Use your data. This is something most people didn't do. They reported data, but they didn't use it to say anything. Here was one of the few students who made a nice graph of data and used it. The higher density of smooth brome was found on the west aspect. They give the mean and the standard deviation, while the northwest slope contained very little. Again, the mean and the standard deviation, and figures, it says figure 2, and then the opposite of true is true of blue bunch wheatgrass. The density of blue bunch wheatgrass was higher on the second site and lower on the west aspect. So again, taking a look at the data and actually using it to make conclusions about the data, and also saying what the standard error bars mean. Okay, here's another point. Don't include the raw data. Use only summarized data in the memo, so make nice tables or graphs, only summarized data. Attach data in an Excel spreadsheet or other format and submit it with the assignment. But for the assignment, only use summarized data in the memo. Okay, so what do I mean summarized data? There were very few really nice graphs or tables submitted. There were a few really good ones, but here's an example of a table that has all the right information, but there's some problems that need to be cleaned up. So first of all, anytime you repeat a number, something's wrong. So here the mean and density are the same number, and they should just be reported once. So don't report the same number, don't repeat it. And then there's this kind of quirkiness of the unit squared. Obviously this team didn't know what the size of their unit was. A better way, there's several better ways to do this. Another problem we have to solve is this BWG. It's not a common acronym like BLM. Most people know what BLM means, but what does BWG mean? And so that needs to be fixed. And then one more thing, the table title is on the bottom and really not very descriptive. Remember, table titles go on the top, so TTT. Table titles on top, figure titles on the bottom. So we're going to put the table title on the top, and then remember, titles need to be clear. Remember what I said, that a title should have so much information that if you dropped the piece of paper that your table was on, and you dropped it on the way out to your car and someone picked it up, they should be able to understand it. So it should be understandable without the rest of the memo. So here I cleaned that table up, got a table title on the top, and it says the mean density along 2 transects examined at the Wheeland Cemetery Remnant Prairie on September 11th. It's important to put the time of year and the date. Blue bunch wheatgrass, western yarrow were examined in plots that were 0.96 feet squared. Okay, I know the plot size because one of the other team members mentioned that. Remember to use if you can use the full name, use it. Then people won't have to remember what an acronym is. So in this case, blue bunch wheatgrass, western yarrow, we have the density, we have the standard deviation, the confidence interval. Okay, take a really close look at that data and just try to make some conclusions on what it's telling you. It's kind of hard to compare, so a better approach for the data that we had in this assignment would have been a graph. So several people used graphs, and now it's really clear that transect 1 had higher density of both blue bunch wheatgrass and western yarrow than transect 2. But if you add these confidence intervals, these 95% confidence intervals, you can see that there's not really significant difference. It's just that there seems to be fewer plants on transect 2. Okay, what it do when you forget things? It's inevitable. You're going to go to the field, and no matter how well trained you are, you're going to forget to write something down. So write down as much as you can. Take as many pictures as you feel comfortable taking and can handle, but you're going to forget something. So what do you do when you forget something? Several people forgot or didn't download their pictures. Well, there's lots of pictures on the web. Here was an example of a student who went on the web and found a person who had taken pictures of the cemetery and cited that person in the graphs. Of course, you can also use Google Earth. Several people did clip pictures out of Google Earth, and you could have gone back to the transect. So there's ways to handle not having pictures. The most common thing that people did on this assignment was to forget the plot size. That happens. You're just learning. I didn't emphasize that we should remember the plot size, but you learn lessons the hard way. And here was how one student handled that. She said that the density of blue bunch wheatgrass was 0.1 plants per plot with a standard deviation of 0.3. So this person did have the mean and a measure of variance, which is very important. And then the density of yarrow is 0.5 plants per plot with a standard deviation of 0.6. And then the student wrote, note that I emailed the professor and the TA to find out the dimensions of the plot, but they did not respond. I will get the precise density in metric measurements to you as soon as they respond to my email. Sorry for the inconvenience. Okay, at least we know that this person has tried to reach out and tried to figure out the measurements, and will send them to Dr. Reiser when she finds them. Okay, it's probably not a really great idea to throw your professor and your TA under the bus on this one. You could have just been more clear, saying, I neglected to write down the plot size, and I'll send it to you as soon as I can. Another way to do it would be to just estimate the plot size. A plot could be everywhere from the size of a quarter to a half a hectare, so maybe just giving a few dimensions would be useful. So here was a second approach. Note, I neglected to record the plot size when I was in the field. We used a square plot that was about 1.5 feet on each side. I will contact my team members and the project lead to determine the actual size and send a brief update when I complete the calculation. Sorry for the inconvenience. Okay, in this case, at least they gave an estimate. All of you could have thought about the plot that you had and at least given some sort of an estimate of the plot size. So I can't tell you what the right way to do this is. Of course, the best way is to write the plot size down in the field. But when things happen, just try to give the best and most honest estimate that you can. There was a lot of confusion and frustration in dealing with scientific names, and probably every class has a different convention to it, but there's 3 things to remember as you write reports in this class. First, underline or italicize scientific names. That's true across all disciplines, whether it's plants, animals, microbes, is that you underline or you italicize plant names. Secondly, it's hard to decide which to use, the common or the scientific name, and that depends on the audience. If your memo is to be directed to a homeowner or a landowner or a 5th grader, then you're going to want to use common names. If you feel it important, you could put the scientific names in parentheses after the common name. On the other hand, in this case, we were writing to a professional. We were writing to Dr. Reiser, who has a PhD in botany. So he would be comfortable with either name. And so I accepted either name. It really is not a big deal in this assignment because we were writing to a professional. Generally, I like just using common names, but it's whatever you're most comfortable with. One important point, though, avoid the field codes. Don't write reports with those field codes like PSSP 6. In the field, we talk a lot about, Brotec and EggSpic, but those aren't really names. They're just shorthand for field codes that we use. So try not to include them in your written reports. They're field codes we use when we're out in the field. So try to avoid them in your memos. Okay, most of the memos were quite well written. I was happy with that. But a few people are having trouble with that technical writing style. 3 little tips. 1, less is more. It's not about sounding interesting or writing an essay. It's about getting the information across with as few concise and accurate terms as you can. So less is more in technical writing. Also, technical writing is not conversational. These memos need to be pleasant and positive, but you don't need to say, for example, thank you so much for spending your time. I learned a lot. I had a really great time. It was beautiful weather. That's conversational. That's like a letter that you write to someone. In this case, it's just about getting the information across. So the last thing is you're just trying to convey information. Don't really want to know a lot about your opinion in this case, or how you feel about it, or what you think was cool. I want to just know the information. So cut back from trying to be so interesting in your writing, and now try to be more concise and more direct. It'll be a little bit of a hard transition, but keep working on it. Another thing that to me makes memos easier to read is when you take the figures and the pictures and put them right in with the text, like this writer did. Just embedded the picture right in with the text. It's a lot easier to see what's going on. I don't have to go to the end of the document and see where the data are. So I prefer to just have the tables and the figures embedded right in the memo. I'm not going to take off for it either way because different agencies, different people have different preferences. But for me, I think it's a lot easier to follow a memo if the figure or the title are right embedded in the text where they are discussed. Okay, then I do give 10% for what I call exceptional input, when you really go above and beyond. And on this assignment, there were 3 really good examples. I'll show you 2 of them of people that really did go above and beyond and actually made something of it. The first one is an interesting one where a student did some research and looked at the dates on the grave. And so they have the number of they talked about how many graves were out there, and the oldest one being right before 1880, and the newest one being in the 50s. There was one aberrant grave that was a 2003, but this person went in and summarized the graves. Okay, that's not interesting in terms of it's not related to what we were asked to discuss in this report, which is how to do a sampling protocol. But this person not only measured the graves, but they also said that once we match each plant to how long it was introduced in the cemetery, then we can estimate how much the cemetery has changed over time. So, for example, if you go to a grave that was dug up and the person was buried in early 1900, we know that soil right around that grave was disturbed in about 1900, and that any plants that were introduced were probably introduced about at that time. So what this person suggested was creating a protocol, which is what we were asked to do, based on the age of graves. So I don't know if it'll work, but it was a cool idea, and they used the data that they had at hand. Here's another one where the student just did an exceptional job of finding a good paper to support their data. So the person found a paper by Hansen et al. From 2008, and that paper was called The Influence of Soil and Site Characteristics on Palouse Prairie Plant Communities. It was done from right around here in Moscow. It was published in a reputable journal, and in that paper the writer of this memo said that the soil type, aspect, distance from edge, edge type, vegetation structure, and slope influenced the plant community of the Palouse Prairie. What was exceptional about this is that this person not only read the paper, but they related it to their results. And at some point they said there was a huge difference in the average based on these transects, where the transects were located. Transect 1 was located within 50 meters of an adjacent wheat field where cheatgrass was abundant, and transect 2 was located in the middle of the cemetery, away from encroaching plants where blue bunch wheatgrass was more abundant. So they read a paper, and that's not exceptional. What's exceptional is that this person related what they read to their data. So again, I'm not interested in just cool stuff that you thought of out on the prairie. I'm interested in relating it to the data that you have or to the question that you were asked. Many people went way above and beyond and gave incredible recommendations for how to manage this plot. Dr. Reiser never asked us about management protocols. He asked us about looking at density measurements and about protocols for the future. So protocols, not management, but measurement protocols. So those were just a few tips. I hope that helps as you prepare for the next memo.